This video series is to introduce some elementary concepts of mechanics. Once you understand these concepts, it will be easier for you to follow the lectures. Mechanics can be broadly classified into two types: statics and dynamics. This course will only focus on statics. We will mainly study a single object which will not move. In a few weeks, we will study a system which consists of many objects. What is force? Force is the most basic concept in statics. Long time ago, Galileo had discovered two objects with different mass, dropped with the same acceleration. However, he could not explain this phenomenon until Isaac Newton developed a more systematic description of forces. To commemorate him, we use Newton as the unit of force. Two types of forces: contact force and gravitational force. In general, we can classify forces into two types: contact forces and non-contact forces. For example, when two objects are in contact with each other, there will be forces between them. These are contact forces. Here, the football is in contact with the ground. The support force provided by the ground to the ball, also known as reaction force, is a contact force. The weight of the football is called gravitational force, which is a non-contact force, because there is no contact between the center of the earth and the ball. To describe a force, we need to know its magnitude and direction. In other words, force is a vector. You should have learned vector in your university mathematics course. Balance of forces in vertical direction. Here is an example. When Spider-Man is hanging in the air in static condition, there are two forces acting on him. The first force is the gravitational force, his weight, pulling him downward. Another force is the contact force from a wire, pulling him upward. Suppose the mass of Spider-Man is 76 kilograms, and the gravitational constant is 9.8 meter per second square. Then, the magnitude of the gravitational force, F1, will be 76 times 9.8, that is 744.8 Newton. Because he is not moving, the forces F1 and F2 cancel or balance each other. In other words, the sum of forces F1 and F2, or also known as the net force, must be zero. Therefore, the magnitude of the upward force F2 is equal to 744.8 Newton 2. In addition to magnitude, we also need to find the direction of the force. In this example, if we treat downward force as positive, then the upward force will be negative. Or, we can use the angle measured from the x-axis to represent the direction. That is, F1 equal 744.8 Newton and 270 degrees anti-clockwise from x-axis. F2 equals 744.8 Newton and 90 degrees anti-clockwise from x-axis. Now, let's look at the boss, Thanos. His mass is 477 kilograms. If the gravitational constant of the planet is 9, then the gravitational force will be 4,293 Newton. Suppose both his feet have the same reaction force from the ground, then what will be the force acting on each foot? Using the same principle as in the previous example, we just add up all the forces in the vertical direction. That is, 4,293 plus 2F equals 0. We have F equal negative 2,146.5 Newton. Negative means they are pointing upward. Now, consider another situation. There are four forces acting on Thanos: his weight, the reaction forces from ground, and the pulling force. We know the weight, F1, is 4,293 Newton. assume that his feet have the equal reaction forces. If the pulling force is 3000 Newton with a clockwise 30-degree angle and they nose is not moving, then what will be the force on each leg? We know the net vertical force is 0. To find the resultant force, we need to resolve all forces into x-axis force, Fx, and y-axis force, Fy. Resolving forces in two directions. The method is simple. For a right-angled triangle, we know x over L equal to cosine theta and y over L equal to sine theta. That means x equal L times cosine theta and y equal L times sine theta. Similarly, the force F can be resolved into Fx and Fy, where Fx equal F times cosine theta, Fy equal F times sine theta. When theta is 30 degree, Fx will be 2598.1 Newton, Fy will be 1500 Newton. Balance of forces in vertical and horizontal directions. Okay, now, come back to the example. We only need to resolve all forces into x-axis forces, Fx, and y-axis forces, Fy. Then, add up all x-axis forces and y-axis forces. For the reaction force, S, on each feet, it can be resolved into Sx and Sy. Because they nose does not move in the vertical direction or the horizontal direction, the net forces in these two directions must be 0. In other words, the sum of x-axis forces is 0, and sum of y-axis forces is 0. So, we easily can get Sx equal minus 1299.05 Newton and Sy equal minus 1396.5 Newton. Now, we know Sx and Sy. Then, what should be the reaction force, S? This is simple. By using Pythagorean theorem, the magnitude is equal to the square root of the sum of squares of Sx and Sy. That is, 1907.29 Newton. The direction of the angle will be arctangent Sy over Sx. That is, 47.07 degree.